Okay, so we're going to continue with lesson 6, which is just some more properties of exponents. There's a lot of properties, but the nice part is that you don't have to do them in order. It's not like PEMDAS. So as long as you understand the properties and know the properties, you don't really have to put them in order. So let's just go through some more. The two properties we're going to do today are kind of linked. It's called quotient of powers. And the idea is, what do you do when you have 2 to the 10th up here and 2 to the 3rd down here? I'm going to actually start with this one over here. It's a little bit easier to write out. So let's say we have 3 to the 6th. On the bottom, we have 3 to the 2nd. Well, kind of like when we did our fractions back in 4th, 5th grade or whatever, I can eliminate these, and I'm left with 3 to the 4th power. So that's one way of doing it. But again, if you're an example like this, 2 to the 10th or 10 to the 9th, you might not want to write all these out. So one of the other shortcuts you can do is just simply take the numerator, the power of 6, and the power of 2, and just subtract them. 6 minus 2 is 4. So for this one, 10 minus 3 is 2 to the 7th. 9 minus 3 is 10 to the 6th. You go down here, what number, when we take away 5, gives us 7. Just slightly different thinking, but that's 12. Here, anything will work. So you can have 7 to the 5th over 7 to the 3rd. Or you can have like 7 to the 20 over 7 to the 18. Anything like that will work. And then here, b to the 5 over b to the 3rd is b squared. Again, all I'm doing here is just subtracting exponents. So the pattern is just simply subtract. So pretty straightforward. Subtract the exponents. What mistakes would you expect students to make? The biggest mistake I see as a teacher is they start, so for example, let's say you have 5 to the 5th over 5 to the 3rd. I see students trying to cancel these 5s or something to that effect. Keep in mind, if you have these things that are the same, just subtract the exponents to get 5 squared. Don't go anything, don't start simplifying anything else. Just go to here. Now, where this kind of relates is, and I'm going to show you, because sometimes you can actually subtract and get negative exponents. So what do you do in that case? Well, let's look at this pattern. 16 divided by 2 is 8, divided by 2 is 4, and I'm just reducing the power of the exponent. This is 2, anything is 0, power is 1. And if you notice the pattern here, 8, 4, 2, 1, I'm just dividing by 2. So this should be 1/2, 1/4, 1/8, 1/16, 1/32. If you go to your calculator, 5 to the 4th is 525, 125, 25, 5, 1, 1/5, 1/25, 1 over 125, etc. And what you should notice is that these negative exponents are just fractions. So 5 squared is 25, so 5 to the negative 2 is 1 over 25. So you can write that rule any way you want to put it in your own words, but just understand that when you have something like this, it just becomes that. The negative exponent, you can move to the denominator and become a positive exponent. Anything to the power of 0 equals 1. I don't care what it is, that holds true. And if you look at the common errors of simplified negatives, it's really just not understanding the rule. So if you look down here, let's just kind of go down here and look. 5 to the negative 3, this is the same as 1 over 5 to the 3. 2 to the negative 4 is the same as 1 over 2 to the 4. This right here is the same, we flip them. So it should be 2 to the 3 up top and 1 to the 3 on the bottom. And that's it. That's how your negative exponents and division work.